Oh, lazy daisy. Okay. Hey, 403 to the HAZ, Mr. Nelson here. And we're just gonna kind of part two of the last video, but we're adding, so we're talking about identities, and we're just playing around with these things, and hopefully, as you see, the hardest part is really determining the non-permissible values. And the non-permissible values are going to be the non-permissible values of each individual identity, but then also how they're stacked up. So what I mean by that is if I have something like secant x over sine x. Basically, the question is, okay, are there any non-permissible values of each individual expression? And in that case, I have to write them out. And then there's also, okay, and also what's going to make my denominator 0? So that's where we get our non-permissibles from, is from each individual identity, and then whatever is going to make the actual denominator also 0. Okay? And that's what we did in the last video. So now we're going to add one more set of identities, and that's the Pythagorean. I'm going to put them with my blue that doesn't work there. So I guess we'll just use black here. These are my Pythagorean identities. And they relate to the squared versions of my identity. So the first one we got is cos squared x plus sine squared x, or theta, is equal to 1. There's 1. Here's the next one. 1 plus tan squared x is equal to secant squared x. And then cotan squared x plus 1 is equal to cosecant squared x. Okay? This combined with that is our magic. But let's talk about the squared terms. How do I evaluate cos squared of x? Say if I said x is equal to pi over 3. Okay? Well, all you do is you can just rewrite this as cos of x squared. Okay? That's how you deal with it. That's how you can, at the end, deal with it. So what is cos of pi over 3? Cos of pi over 3 is x here, 1 over 2. So cos squared, so 1 over 2 is cos of x. So then when I square that, I get 1 over 4. Therefore, cos squared of pi over 3 is equal to cos of pi over 3 squared. And I get 1 over 4, okay? Or 1 over 4. So the big kind of precursor rule is when I have a cos squared or a sine squared or a tan squared or anything, it's whatever that the cos is, the non-squared term, or the first degree cos squared. So let's, I'm just fumbling my way through here. So let's use what we know to just answer some problems, okay? The first one is from the textbook, page 296, 3b, okay? And they basically just say, simplify this expression into one of the 3 primary trig functions, sine, cos, or tan. So they want this to just be simplified into sine, cos, or tan. Okay? So what I'm going to do is I'm just going to convert all of the terms here into their basic trig version. So secant I can rewrite as 1 over cos x times cotangent is cos x over sine x, and then sine squared x can stay the same. And now I'm just going to cancel terms. Cos cancels with cos. Sine cancels with 1 sine x. So I'm left with sine x. So this simplifies down to sine x. Let's do another one. So this is number 4C. Okay, and they're saying simplify and then rewrite each expression as one of the 3 reciprocals. Okay, so they want the answer to be either cosecant, secant, or cotangent. So we're simplifying cos of x over 1 minus sine squared of x. And 1 minus sine squared of x is the same as cos squared of x. So from this identity, 1 minus sine, and I mean, the fact that there was a squared term was a hint that, okay, we're going to have to use these identities too. Math at this level basically kind of nudges you towards the right strategy. So in that case, if I isolated for cos squared x, it'd be 1 minus sine squared x. So I can rewrite this as cos x over cos squared x. And then 1 cos would cancel with 1 cos, and I'd be left with 1 over cos x, or secant x. Okay, that's the answer, secant x. Okay. I'm going to do 5A, B, and then 7. So I'm going to do 5. Okay. I've got secant x over tan x plus cotangent x. And they say for A, verify is equal to sine of x. And they say verify that this is true for x is equal to 30 degrees and x is equal to 45 degrees, but they give it to us as pi over 4. So first thing, let's turn x is equal to 30 degrees into radians. So we multiply it by pi over 180, so we get 30 pi over 180, or pi over 6. Great. So they want us to check that this is true for pi over 6 and for pi over 4. So let's do that. So let's solve each of these individual terms, and then we'll be able to go there. Well, so let's figure out what sine of, okay, getting ahead of myself. Let's do pi over 6 first. X is equal to pi over 6. So the first thing, let's check what we're trying to get it to. So sine of x, or sine of pi over 6, pi over 6 is right here. Sine is the y, so it's 1/2. Okay, so 1/2. We got to make sure that the left side is equal to 1/2. So let's do each individual. Secant x is equal to 1 over cos x. And 1 over cos at pi over 6, cos of x is root 3 over 2. So it's 1 over root 3 over 2, which is 2 over root 3. So secant x is equal to 2 over root 3. Tan of x, or tan at pi over 6, is going to be the far side, 1 over root 3. So it's going to be 1 over root 3. And then cotangent of x is cos x over sine x. So it's going to be our x coordinate over our y coordinate. So at pi over 3, remember, every coordinate here is cos of our angle, sine of our angle. So our sine is always our y, cos is always our x. So cotangent is cos x, so it's going to be the x coordinate divided by the y coordinate. Right? And here, so let's go back a step. So tan of x is equal to sine of x. Sine of x was 1/2 divided by root 3 over 2. And then the 2's will actually cancel with each other, leaving me with 1 over root 3. So I'm just, and then cos of x is now the opposite. It's root 3 over 2 divided by 1 over 2. And then the 2's will cancel and I get root 3 over 1. Okay, there we go. Now I have all the ingredients to check that side. So let's check it now. And I'm going to check it. I'm going to check it right here, knowing that it's pi over 6. So it's 2 over root 3 divided by 1 over root 3 plus root 3 over 1. What a mess. But let's keep going with it. So, sorry, I have to erase this so I have space because everything's just fucking, everything's getting taken up here. It's been a while since I haven't had kids in the class. Even though I swear with this students. Okay, here we go. So let's do the math here. I've got 1 over root 3 and I'm adding root 3 over 1. And I need a common denominator to be able to add these two together, and it's clearly going to be root 3. So so 1 over root 3 is just the same as 1 over root 3. So what is root 3 over 1 as an equivalent fraction out of root 3? Well, I got to multiply both sides by root 3. So that's the same as 3 over root 3. Because root 3 times root 3 is root 9. There. So now this is equal to 1 over root 3 plus 3 over root 3, which is 4 over root 3. So then this becomes 2 over root 3 divided by 4 over root 3. And the root 3's will cancel, and I'm going to be left with 2 over 4, which is 1 over 2. So the left side is equal to the right side. You might want to rewind that. I just solved this myself for the first time, so it's doable. Okay? So that's how we kind of solve those things. I did it for pi over 6. The next one they asked for is when x is equal to pi over 4. So you can go through and just replace pi over 6 with pi over 4 and see what you get when you go through it with basically at this point here, pi over 4. Okay, now let's do one. So this was kind of like a kickback to the last video. So now let's do number 7, where we actually have some squared terms in there. So they say, when polarizing lenses are rotated through an angle theta over a second lens, the amount of light passing through both lenses decreases by 1 minus sine squared theta. Determine an equivalent expression for this decrease using only cosine. Okay, so A is that relationship is basically equal to cos of theta, cos squared of theta, because cos squared is equal to 1 minus sine squared. So that's using only cos. That was A. B, they ask, what fraction of light is lost when pi is equal to pi over 6? So this expression was the amount of light lost. Yeah, decreases. Wait. Yeah, that's the amount of light loss is this equation. So let's evaluate that equation at pi over 6. So to do that, it's going to be 1 minus, remember, sine squared of theta is the same as sine theta squared. Okay, so what's sine at pi over 6? Well, sine at pi over 6, sine is my second coordinate, it's 1 over 2. So this is the same as 1 minus 1 over 2 squared, or 1 minus 1 over 4, which is 4 over 4 minus 1 over 4, which is 3 over 4, or 0.75. That's B. And then they want us to do the same thing when theta is equal to 60 degrees, and 60 degrees we know is pi over 3. So you can go through and go do this for when pi is equal to pi over 3, and you're going to end up using root 3 over 2 and squaring that, and then subtracting that from 1. I think that's enough to get you guys going. Yeah, so I'm going to end it there. Good luck.